It's 1687. Isaac Newton drops a right club banger called Philosophiae Naturalis Principia Mathematica, introducing his physics of gravity. However, it could be argued, and it will be because I'm going to, that perhaps his biggest leap was his idea that the rules down here on Earth world are the same rules that are up there in space world. So if a theory of gravity works for apples, which never fell on his head by the way, that's bollocks, then it will work for stars, galaxies and black holes too. Sounds obvious enough to us living in the future, but it was revolutionary back then and it changed physics forever. And anyway, what did you ever do? Bugger all, probably, so just shut up. Anywho, that eventually led to the discovery of Big G, or G. G is the gravitational constant, and it guarantees that wherever you go in the universe, the attractive force of two objects will always be proportional to their masses and inversely proportional to the square of the distance between them. The point, as far as we know, is that Big G never changes anywhere in the universe ever. It's a constant, and constants are important because the universe is as mad as a bucket of coked up ferrets, and depending on where you are or what you're doing, the speed of time can go wibbly, the local strength of gravity can change, denoted by little g, or G. Mass, momentum, everything is variable. We need things to hold on to if we want to know what the really real rules of the universe are. So if you're feeling social, let's meet some of the fundamental constants of reality, the rules that dictate everything. And the speed of light. Doesn't matter what you're doing, how fast you're going, or if you wish your girlfriend was hot like me, the speed of light in a vacuum never changes, as far as we know. That means if you're going at 1 meter per second, then the speed of light is traveling this fast away from you, and if you're going at 298 million meters per second, then the speed of light is still traveling this fast away from you. If the speed of light doesn't change, ever, then everything else has to change around it, like time and distance, and that's partly where we get relativity. Anyway, it's called K, and it's a constant. Cool. Tu. The fine structure constant. This is alpha. It basically denotes how strongly electromagnetism can f with charged stuff like protons and electrons, and it comes out as 137. That number is so fundamental to nature that if aliens contacted us, before we replied with nudes or pictures of cats, sending 137 might be the best proof to them that we are big boys and big girls now, and come say hello please. To there. Planck's constant. Planck gave us h, which basically defines the relationship between a wave or particle's frequency with its total energy. For one thing, it tells us that energy actually comes in little packets called quanta, and from that we also get the Planck length, mass, time, charge, and temperature. These are the master units of reality. They're not defined by silly human measurements, they're made of other constants. If there is a god, he's probably using these to boil his tea and put up his shelves. Theater. Finally, the mass of the proton and the electron are also good yardsticks for the universe, since they don't change as far as we know and they come in at these values, but I don't know what they are yet because I'm writing this script on the bus and I consider internet on mobile phones to be the pinnacle of millennial degeneracy. Now, that's all very interesting, you might say, but where do the constants get those values? Well, before we fail to answer that, it's not just the constants that are set up rather specifically in our universe, it's everything. Hey, this is cool, huh? So, fundamentally, we live in three-dimensional space. So we live in three-dimensional space with one time dimension, which is fine, but it's not too silly to imagine a universe that could have been set up with only 2 spatial dimensions, or 4 even. And what would 4 look like? So you have the usual vanilla X, Y, and Z axes, and let's add one more for funsies called W. This is a 4th dimensional axis, so we've added a whole new dimension to space. Now it's a bit difficult to conceive of because we're built for 3-dimensional thinking, but you can see as you vary the 4th dimension in the environment, everything goes a bit, to put it mathematically, totally up the So objects are moving through a dimension we can't see, and to us, disappearing. We know this is mathematically possible. You could have a universe that works like this, or with even more dimensions, but the point is, we don't know if 3 dimensions is the only spatial way to do things. We just happen to find ourselves living in a universe with them. Why is our universe only 3-dimensional with one time dimension, as far as we're aware? No one has a clue. It's not self-evident. Time for a personal anecdote. As the icing on my genetic cake, I was born more or less blind in one eye, and worse, it would just wander off sometimes if it got bored. It really was a piece of shit. And in the prime of my adolescence, I felt a touch conscious about this. So I went to a doctor and asked, and he said, yeah, sure, let's get it sorted. Fun side note, what I didn't expect was that a while before the operation, to check you won't get double vision from the surgery, they inject Botox into you, surrounded by 15 very attractive student doctors while you try to pretend you're totally fine with a needle in your eye. Anyway, a while later they put me to sleep and I woke up with some bandages, and then I didn't really have a lazy eye anymore. And that was it. A few months passed and the novelty wore off, and then I got to thinking, how did they put me to sleep anyway? What is this anesthesia nonsense? And I looked into it because I didn't know how anesthesia worked, and as it turned out, no one else did either. We know general anesthesia stops vital areas of the brain talking to each other so you can't form memories, and we assume you're unconscious too, or we hope so. But we don't understand the mechanism yet, and I couldn't believe this. So we're using this thing thousands of times a day for opening people's skulls and rib cages and all sorts, and we don't even know how it works. And then you start to notice this pattern everywhere. The things we use and trust all the time without any knowledge of the mechanism behind them. Our languages, our medicines, the biology underlying sleeping, or what sleep is even for, consciousness, imagination, and then finally just the world. Why natural laws work or are there at all. We know they keep going, we know we can wrap them up in equations, but we don't have a clue what they are. Ever since then, I've never been able to let go of this horrible feeling that we're living on the top of this enormous iceberg, and we've drilled down like a foot into it, but there's still 400 miles of the thing below us that we can't see and we don't understand. Yet here we are, living on top of it, just going about our lives as though everything's fine. And it all comes back to the constants. Start with any phenomenon, the fizziness of lemonade, the collapse of the Qing dynasty, the antics of Juice Bigelow, male gigolo, and keep asking why it exists or why it happened, and eventually you'll come back to the fundamental physical constants, to the rules of reality. Every explanation stops somewhere, and it almost always stops here. So where do the constants come from then? Well, maybe God/digital overlords. Regardless of one's religious persuasion, it is possible that an intelligence set all this stuff up. On a similar note, it's getting all fashionable of late to suppose we're living in a simulated universe where physics is determined by someone or something else above us. Maybe. Presumably though, whoever's running the simulation also lives in a universe with laws, so what determined those laws then? Also, have you ever noticed every time we invent a new technology, that becomes the metaphor for everything now? If you've got a hammer, everything's a nail. Psychology used to be really into theories about compression and diversion of pressure. I wonder where those ideas came from. Likewise, recently we're getting really into the idea that lots of stuff is computation and simulation. I wonder where those ideas came from. No doubt we'll invent other clever stuff in a few decades, and that will be the new bee's knees in our theories. Just saying, reality is really complicated, and maybe we don't have the right metaphor yet. Maybe we do. Anyway, variation over time. Another possibility is that the constants aren't actually constant. They might be slowly getting stronger or weaker. This isn't that uncommon an idea, so the speed of light might be slowing down, for example. There's a whole class of these called VSL, variable speed of light theories. However, firstly, we don't have any definitive proof that the constants are varying yet. There is a possibility that alpha, the fine structure constant, is varying, but again, we don't know. The thing is, if the constants are constant, we don't know why yet, and if they aren't constant, we also don't know why yet. So maybe multiverses? A bunch of constants we found are set up in such a way that if they were just a little bit different, things would be catastrophic, for us anyway. If gravity had been stronger or weaker by just 1 part in 10 to the 40th power, then stars probably wouldn't have formed at all. So why is our universe so cuddly and well made? Well, maybe there are squillions of other universes, all of them with slightly different constants. Why are the constants the ones we see? Because we live in this universe, not these ones. It doesn't then explain why there are squillions of other universes in the first place, but still, it's getting there. And finally, hard logicality. Another fun theory is that there's something special about our constants and our physics, that they're baked necessarily into reality. And I made the term up, so there's no point googling it. Like, it's tricky to imagine a universe where pi doesn't dictate the ratio of a circle's circumference to its diameter, unless that universe had a very weird and different geometry. It seems like pi is built into logic. The idea is that the mass of the electron, the electric charge of the top quark, the furniture of reality, all of this stuff also derives from logic somehow. That all of matter pops out of, say, pure geometry. And one day we'll find the necessary bridge between the two, and everything will be explained from the bottom up. Anyway, right now we know lots about what the rules of reality are, but almost nothing about why there are these rules. And it seems like we should be talking about that a bit, because if particles and waves and space and time and us are the marionettes, there is a ghost above the stage pulling the strings, dictating how they and we behave. And we don't know what that ghost is. Why is physics even here at all, and what the hell gave it its character? Einstein once said, "What really interests me is whether God had any choice in the creation of the world. As in, is this the only way you can make a universe? And what is the origin of the structure of reality?" Likewise, Edgar D. Mitchell was one of the 12 astronauts to walk on the moon, and he said the most amazing part of the trip was the return journey, when he was looking out of the window of the capsule and he could see the Earth and the moon and the sun, and he suddenly realized that every molecule in the spacecraft, in his body, in the other astronauts' bodies, had all originated from some ancient star, and he had this overwhelming sense of unity. It was all the same Lego bricks, all part of the same game, the same cosmic terms of service. And it's no different for you and I. Just having thoughts in the first place is made possible by electromagnetism conveying signals between the neurons in our brains, plus holding our molecules together, as well as the strong interaction kindly keeping the nuclei of our atoms, specifically the protons and neutrons, in place. Meanwhile, the curvature of space-time, gravity, has been keeping us from casually leaving the ground like Balloon Boy and going for a quick wander through a passing jet engine. Meanwhile, the weak force has been quietly keeping quarks transmuting, regulating the nuclear fusion that powers the stars, some of which, billions of years ago, prototyped all the carbon, nitrogen and oxygen in our bodies, allowing us to exist in the first place. And all of this has been facilitated by the fundamental constants of nature, obeying the speed of light, gravitational constant, and all the rest. The buttons the universe has done her coat up with. You know, I don't have the charisma, looks, or predilection for orgies required to start a cult, but if I did, we'd need something to dislike. And that would be this weird recreational cynicism one comes across sometimes, that the world is boring and everything's been discovered. Has it? Has it? Really? Oh, I must have been on the toilet when that particular ontological memo came through. Isn't it nicer and just more honest in a way to admit we don't have a handle on anything yet? That there's nothing normal about reality, it's just an insane jigsaw puzzle devised by a madman that's persisted long enough for us to accept as routine. And in a predictably ungrateful fashion, we still somehow invented a word for boredom. I don't know if you're having a time right now. Maybe work sucks, or you're in a pinch, or whatever, and I'm really sorry to hear that. But may I recommend that it is possible to put stuff into perspective just for a moment by remembering that every atom in your body is the direct result of universal laws we have no idea to the origin of. That there is, in plain sight, a mystery called everything, and nothing is self-evident, and really, if we're honest, we don't even have a clue what the reality is doing here in the first place.